All right, so for today, we are doing day 4 of complex numbers. And for today, it's DeMoivre's formula. And it sounds really impressive, and it's actually incredibly easy. And the main idea is, how do you multiply things that are in cis form? Well, what the heck is cis form again? That's not in cis form. I want you to change that into cis form. My opinion, easiest way is draw a picture. I'll pause for a second while you do that. All right, so let's see how you did. Did you figure out that 3 to the right and down 3 would be like down there-ish? Raise your hand if you had that spot right. Okay, good. Oh, no? Dang, I did it backwards. What a great way to start a video. Okay, we'll go 3 to the left, and then, okay, because that's negative 3, so it's 3 to the left, and then up 3. How about there? Is that better? Okay, good. And for those of you that just always agree with me, there, you got burned. All right, and I wasn't trying to test you or anything. I just screwed up. All right, so now let's try to figure out how long this is. Well, if this is 3, and this is 3, actually negative 3 just because of the direction it went, then I'm going to use my classic 1 root 2 to say, oh, looks like it's 3 times bigger. So I'm going to say 3 root 2. Raise your hand if you had the same thing as me. Excellent. Then, what's the angle? Well, this angle right here has to be a 45, but do I say 45? No, I don't. Because if I said that this was r, 3 root 2, cis theta of 45, I would be implying that it was over here. That's a different place, isn't it? All right, so that's not a 45. It's a whole bunch of 45s, and we should really do it in radians. So it's a bunch of pi over 4s. So did you say cis 3 pi over 4? Raise your hand if you did. Okay, excellent. Now, one little note, and something that I haven't talked to you about much, but once we go past pi here, when you're doing this unit, complex numbers, sadly, another little set of rules kick in. Do you remember when we were doing inverse trig? This became negative pi over 2, and this whole area was the negative zone. And when we were doing inverse trig, this was the dead zone. Nothing could be here, etc. Well, in complex, there's special rules too. And it goes like this. This area right here is all normal, and it's the positive zone. And thankfully, most of the problems we've been doing have been in there. But I did actually mess one up yesterday when I went over here and I said it was 7 pi over 6. I should not have said that. Because with complex, not only this area is negative, this area is also negative. So I can't say that spot is 7 pi over 6. I got to go the other way. This whole area has to be done in negatives. So the angle would be negative, well, if that's a pi over 6, a bunch of pi over 6s, negative what? Negative 5 pi over 6. I shouldn't have said 7 pi over 6. Same as the other. I mean, they're both the same place, but, it's a big but. You have to be careful with where you use negatives and where you don't. With inverse trig, you use negatives here. When you're doing these polar form of complex numbers, this whole area is negative. So let's say that we got done drawing our triangle, and it was over here. Can you get how, if this was like pi over 3, and this was like negative, now let's use the numbers that are the classics for the 30, 60, 90. That makes this a 30, right? And that makes this a 1, 2, root 3, make some negatives. Do you get how it'd be really tempting to say that the cis form of this would be 2 cis, a bunch of pi over 3s, and you'd say 4 pi over 3, and you'd be wrong. I'd have to mark it wrong. Okay, what should it be? All right. I normally don't have a problem with doodling, but your doodling is so loud right now. It must be the crinkly paper or something. Please, don't distract me. So this is a whole bunch of pi over 3s the other way, and that should be negative what? 2 pi over 3. Okay. Message received about negative world. The whole underworld. This area under here All of that is to be done in negative angles. Okay? All right. So, really what today boils down to is teaching you what's called DeMoivre, but that's really only one of three things. And as much as I would like to just summarize this for you in 2 seconds, which I can, I want you to actually practice reading this stuff like you had to teach it yourself, like you had to teach it to yourself. Because sadly, when you get to college, a lot of times the teacher will have so much stuff they need to teach you that they're like, well, you've got to read that stuff and understand it, and then you're going to come to class and I'm going to do the hard stuff. You have to actually learn how to read math. Now, I want one thing, though, that we haven't talked about very much. We keep calling this R. That is the spot for R, but they use this symbol with the bars on both sides, and it's called the modulus. Did I mention that in the word modulus the other day or not? All right. So R cis theta form, the R that you use is the modulus. It's no different than what we've ever done. We always just use that same number. It's the radius length. Okay, so let's say you got a triangle drawn. It's this length. Let's say that's 8. Then in the context of a complex number, if this thing we were graphing was Z, for instance, if its name was Z, then the bars around it means its modulus, also known as its radius. Okay, so when you see those bars around them, they're just like the radiuses, like the R's, like the hypotenuse length in here. See how there's an R there instead of R cis theta? They use modulus Z cis alpha. All right, that's one of the things that happens a lot in real world math is like you got to roll with, oh, it looks like they're using a different variable than I was expecting. They can use any variable to define stuff. So the main thing is we're going to have to know how to product, as in multiply these two guys. Power, take one of these guys to a power. Let's say I wanted to square it. Or quotient them, or divide them. Take this and divide by that. So things that are in cis form can be multiplied, put to a power, or divided. And would you try to learn how to do it by reading that for a moment? I will pause and see if you can figure out how to multiply, put to a power, and divide a couple of complex numbers that are in cis form. All right. So, did you get what was happening right there? Those are really, I hope you kind of translated those into R's in your head. And it's the R from the one and the R from the other, and there it looks like they're sitting right next to each other, which is the kind of the universal sign for multiply them together. And would that make sense in the context of a product? So yeah, so basically you multiply the R's together, and then do you multiply the angles together? No. What do you do with the angles? You add them. Are there other scenarios where multiply and add kind of go together? Sure, let's say I had A plus A plus A, and some smart kid says, can I just do 3 times A? Doesn't that add and multiplying kind of go together? All right. And if we do this in the context of logs, I think you'll see the whole quotient going with subtract. Do you remember when we had log base 3 of x minus log base 3 of 2? Do you remember that when we put them together into one log, that this turned into log base 3 of what? Not x minus 2. That would be minus going with minus. Divide went with subtract. Does that make sense? That's just a little echo from logs. It's been a while. All right, so back to if quotient is where you divide them. Of course, you just divide the two R's. You subtract the two angles. Provided W is not 0. Why did they do that? Because look, W is on the bottom of a divide problem. Got to make sure W doesn't happen to be 0. Could there be an R of 0? No. But Good. All right. All right, so then the power rule is where we're putting something like z, let's say that guy, to a power, and they say the power of n. It could be anything. Like, let's say I wanted to put it to the third power. Do you see how it says that you take the r and put it to the same power? But then you times n times the angle? That's a little weird. Seems like the angle should be to the third power. Let me show you why it's not. Would you agree this is the simplest r cis theta I can possibly have? I don't even have anything in the front of it, because really what's in the front of it then? So it's kind of naked up in front. Full frontal trig nudity right there. All right, so if I wanted to now put this to the power of 3, DeMoivre tells me to take, well, there is nothing in the front of this. I'm just going to do it the old-fashioned way because you don't know what, you just read DeMoivre. You've never actually used it. Would you agree that this means times itself 3 times? Cis theta times cis theta times cis theta. Can't argue with that, can you? And didn't you just learn 2 seconds ago when you multiply them that what happens to their angles, their thetas? They get added. If I add these two, I'd have 2 theta. And if I do it again, take a wild guess what I'd have. 3 theta. So when you have, I'm going to throw in a 1 in front just so that it's got something I can put it to the power of. Now I'm going to write a couple 3's up here, and I think you'll know why in a second here. DeMoivre is all about DeMoivre of the exponent. 1 to the third cis of 3 theta. Do you get how I move the exponent? And I got it. I can't just say put both of them to the power of 3 because the angle gets tripled. It does not go like this. It goes like that. That's 2 different things. Timesing by 3 and putting to the third power are different things. Similar, but... All right, so let's see if you really got that. Here is a typical question. We're going to say z is 2 cis pi over 6. Would you agree that's a fairly simple, nice, clean cis? It even, if you think about it, it even has the 1, 2 root 3 thing working for it. You get what I'm saying by that? If I were to actually make a picture of this, the r is the hypotenuse, is 2, and isn't that where the hypotenuse is supposed to be on the 1, 2 root 3 triangle? Nice, clean one. Okay? Let's make another one. Instead of z this time, let's go with q. Q is going to be 1 minus I. Wait a minute, Mr. Server. You can't multiply something in cis form and something in rectangular form. You're right. So you better figure out what cis form is for that. Then I'd like you to tell me what z times q is. After you have figured out what q is in cis form, you're going to multiply them. Then you're going to take z and put it to the third. And lastly, you're going to take z and divide it by q. Again, first step, get it in cis form. That guy. All right, I'm going to pause for a second while you get that in cis form first, because I don't want you to do all the problems with the wrong cis form. So, okay, I'll pause for a second while you do that. Okay, let's see how you did. First of all, cis form. Over 1, down 1, 1, 1. Okay, so I'm going to get a 45-degree angle, but not 45, pi over 4, but not pi over 4. What? Negative pi over 4. I'm glad you caught that. So if you didn't catch that, you need to fix that, because radius root 2 cis negative pi over 4 is going to play out a lot different than if it had been positive. All right. So now let's actually take this cis and this cis and now multiply them. Would you agree that and that have to get multiplied? 2 root 2 cis, and then all I got to do with the angles is add them. But what's pi over 6 and negative? If I add negative, it's really like subtracting, isn't it? Okay, so now I should get to have a common denominator, because pi over 6 minus negative pi over 4 won't get along real well because they don't have a common denominator. let's make it twelfths. So this will be 2/12, and this one will be 3/12. 2 minus the 3 makes 1/12. This is 2 root 2 cis 1/12 pi, or pi over 12. And I think it's negative, isn't it? Excellent. Raise your hand if you had that one right. All right, that's about as tough as they would get. That's not like super hard, but it involved common denominators. And all right, now let's do a DeMoivre. DeMoivre is about DeMoivre of the exponent. So if I'm going to take z, which was that guy, 2 cis pi over 6, and put it to the power of 3, I'm going to write that with a couple 3s so I can move them. Then this 3, DeMoivre of the exponent, goes like that, and I would have 2 to the third, which is 8 cis 3 pi over 6, and if you reduce that, 8 cis pi over 2. Raise your hand if you had that one right. Sweet. And then the last one is just where you divide them, and of course, dividing kind of goes with subtracting. So you take the these two, the lead numbers, and you divide them. 2 divided by root 2. Now, you may remember that we're not supposed to leave square roots in the denominator, and in this unit, we are going to enforce that. Why? Because this is something special about this unit. This is complex numbers. And we're all big on not having i's in the denominator, so we figure we better be big on not having square roots in the denominator either. So you should multiply by root 2 over root 2, and it becomes 2 root 2 over 2, and then, wait, that all goes away. Isn't that weird? It's just root 2. So 2 over root 2 is the same as root 2. That's weird, but true. You know what I'm saying? Because that's the square root of 4, which is 2, and then I got a 2 on the top that's going to cancel with it. So 2 over root 2 becomes root 2. And then I have cis, and then the angles just need to get subtracted. So that's going to be pi over 6, which will change to 12ths, minus, wait a minute, negative pi over 4. Last time I added them, I should have subtracted them, and I did. Yeah. Okay. Bottom line, this time, normally you're supposed to subtract here on divides, but since I'm subtracting on negative, I'm going to add them. All right, so this one's going to become in 12ths, 2 pi over 12, plus in 12ths, 3 pi over 12, and that makes a total of 5 pi over 12. So, final answer, this one simplified down to just root 2 cis 5 pi over 12. Okay, you have learned to take complex numbers and multiply them, divide them, or put a complex number to a power using DeMoivre's theorem. That's the thing for the day. Let's see if you caught it by going to your homework. I'll pause for a minute. I think it's like page 26 or page 27. Number 45, it should be an easy one as long as we had cis form, but you don't. Look at that. Can I do this without cis form? Unless you want to write that out 3 times and FOIL it out, it gets really messy. So much easier to just put this in cis form. Let's take a second and just put it in cis form. It's going to go to the right 3 root 2, and then down 3 root 2. And, oh, I feel like I recognize this one. This is the same distance as this. It's the 1, 1 root 2 triangle, basically, right? So that's a 45-degree angle. And hopefully you've learned that that's called pi over 4, and in this case, negative pi over 4. So my cis for this guy is going to be the r. I'll save you some time. 3 root 2 and 3 root 2. Once you square them and add them and take the square root, it comes out to 6. Okay. Another way I could have known that is, you remember how you'd multiply one of these sides by root 2? Because it's the 1, 1 root 2 triangle. And if I multiply it by root 2, 3 root 2 times root 2 is like 3 times 2, which is 6. All right, so anyway, I got my r, and the r cis theta, 6 cis theta was negative pi over 4. That's what this is in cis form. Now I'm going to take that and cube it. 6 cis negative pi over 4, and then I got to put it to the third. It's all about DeMoivre of the exponent. So you put 1 to that and 1 there. Notice, and that's multiplying the angle by 3, not putting it to the third. All right, so there's a heavy-duty hint to get you going on those. Those 4 are all assigned. Let's move to the next page. On this one, I can live with you just doing one of them, and 8 is extremely lucky in China, so we'll go with 8 times 8 is 64, would be a great problem to do. And we're going to skip 54 and 56, but do these. Now, it's asking you to do it the way that they've got it, but I'm fine with you changing it to cis form, unless you'd really rather write this thing out 3 times and do all the foiling necessary to no thanks. Okay, it's just a reminder that you can get these things into cis form, and it'll be a lot easier. All right, and then that's it for that day, and that's it for this video. Any last questions? Okay.